Hi guys, Mr. Sutton here. I've got a little graph that I put together that represents the acceleration of a patrolman. It's not terribly realistic, but at time 0, the patrolman starts accelerating at 60 miles per hour square. That's actually really pretty darn slow. He starts accelerating at 60 miles per hour square, and he does that, as you can see from the graph, he does that as x goes from 0 to 1. Then as x goes from 1 to 3, he's not accelerating at all. And then from 3 to 3.5, as x goes 3 to 3.5, it looks like his acceleration is negative. It's a negative 120 down here. Looks like it's probably started at positive 60. So we have a graph of acceleration. But now, just observing this graph of this patrolman's acceleration, it kind of leads us, we see some kind of obvious things. If he accelerates at 60 miles per hour square for 1 hour, at the end of the hour, he should be going 60 miles per hour. And if you notice here, that happens to match. Let's see, if we were to look at the area under the curve, as we go from 0 to 1, so this area in here, it's 1 unit wide and 60 high, so that 60 matches the miles per hour that we believe he should be going at the end of that 1 hour. And of course, we could have cut it off anywhere in here and kind of, so if we had done it at 1/2 and gotten the area, we would have thought he was going 30 miles per hour after half an hour, and we would have been right. So what we're kind of showing here, if you think of the units, let's go back and think of our units. Let's see. The vertical axis is miles per hour square because it's hour squared because we are dealing here with acceleration. The horizontal axis is hours. So just kind of think of the old length times width, because that's the scenario we have here. We got miles per hour squared times hours. If we multiply that out, we got miles per hour. Well, in our very basic example, we're just using length times width, right? That's going to be the same as calculating the area between the curve and the x-axis. So let's look and see if this makes sense. So after 1 hour, he should be going 60 miles per hour. He then's not accelerating at all because acceleration is 0 between 1 and 3 hours. So he's just patrolling. He's just going along at 60 miles per hour along the highway, it looks, in the positive direction. Now acceleration goes negative, but if he was going in the positive direction, it probably means he's braking. And it looks like he's braking actually quite slowly here. It's like for half an hour, he's braking at a negative 120 miles per hour square. So, well, so let's see. So if we were to try to calculate this area, it's below the x-axis. And the area there should be, let's see, x is 1/2, right? Because we've gone 1/2 unit from 3 to 3.5 at a negative 120. 1/2 times negative 120 is a negative 60. So it looks like at that point, the patrolman has stopped. Maybe he's having his lunch. And then there's no acceleration, so maybe he's just sitting. And he just sits for half an hour having lunch. And then, let's see, he goes and accelerates in the negative direction. So maybe he's coming home now. So he starts coming home. And let's see, if we calculated this area, and it's below the x-axis, so we'll call it negative. He's at negative 60, and then so that would be the height, and the width is just 1. So negative 60 times 1 would be a negative 60. So at 5 hours, it looks like he's going 60 miles per hour, but in the reverse direction. He's coming home. Looks like he does that for 2 hours, and then his acceleration becomes positive. So if he's going in the negative direction, his acceleration is positive, must be braking. Okay, so and we can get a sense of what's going on with this guy's velocity. It looks like by calculating, because we got this nice scenario here, we can see how easy it is to calculate by calculating the area under the acceleration curve. So it sure looks here like velocity is the area under our acceleration curve. Wow. I mean, would that be true just for this instance? Or might that be a general truth? And if we were to calculate the area just by doing tiny little rectangles all along, piece by piece, all along, we would actually, what I've graphed here in blue, this is the velocity diagram we would come up with. So we started out no speed because he's just starting. And then say after, it's like he's going 30 miles per hour after half an hour. After an hour, he's going 60. He stays at that 60, and now here's where he's braking. And so this graph, if I just were to plot the accumulated net area, where area below the x-axis is negative and above the x-axis is positive, I would plot this blue graph. So somehow I'm able to go from, in this instance, from acceleration to velocity just by calculating the area under the curve. We'll see more of this in the next video. Talk with you soon.